So thank God I didn't forget. So we are, starting our recording. Let's go. So
Please, can I ask a question?
you can, please.
Okay. Yeah. So when I was doing the assignments, I became confusing at some point
Okay.
because you say you are training a model,
Mm-hmm.
but you're giving me the whole answer. Like I was wondering that you are training it and you're also testing it, but the variable we want to predict is in the testing data and it's also in the training data. Like it doesn't make the model fit in the sense that the data you are, I don't know if you understand what I'm trying to say. You know,
Understand.
when you partition, you are sending the data. Should we not like remove the income we want to predict so that the model won't, I don't really. So
Is that
that's
why
my
you got
confusion.
100%? That's why you got 100%.
No, look at that. No, wait, no. Look at that's the same thing we did also in class. Like I
Yes.
noticed that we
You're
are not removing
passing
the column.
everything,
Why
right?
don't we remove the column?
I'm going
Yeah,
to
we are passing everything.
I'm going
Why?
to I'm going to show you what that is. I'm going to come back to your question when we go to 9. I'm going to come back to your question. So when I get there, I'm going to call you and then we're going to, I'm going to address it so we would align on that. So let's go through the class. This is where we are. We've gone through all this. For those that have not gone through it, go through the previous videos. We've gone through linear regression, logistic regression, and this is the assignment. Now, some of you, okay, when I get to the second assignment, this is the first assignment, Diamond Prize, right? Now, the second assignment, sorry, hold on. Someone is trying to join the class. This meeting does not require a meeting ID, right? I assume. So now, we've gone through classification, which is that there are two types of, machine learning algorithms. We have regression and we have classifications. And we've done a piece of binary classification. We've done a piece of classification, binary classification, which is like the one that was the assignment, which was salaries less than or equal to 50,000 or greater than equal to 50,000. Now, everybody did not finish the assignment, but we'll get there. Now, we've also talked about classification and regression. Regression classification is their discrete items. So maybe separate, try and predict boys and girls. We know it can just be boys and girls, or spoons and forks, or how many cars are in the compound. We know it can just be Audi, Chevrolet, Lamborghini, Ferrari. They are discrete items. But regression can be a range of items. It can be, continuous variables. What do you mean by continuous variables? It means that, it can be 2.568, it can be 3.867, it can be any value and it can change, but it's within a range, right? It's continuous variables. It's not stick. Please, any questions so far? Let me see. Okay, someone is raising up their hands. Joy, are you raising up your hand? You can unmute.
That was for earlier, but I don't think I was just going to talk about my feedback from the homework, but it's fine. We've already moved past that.
Okay. Just give me 1 minute. Give me. Mm-hmm. Okay. I'm assuming it should work. Post the issue on the group. Yes, sorry for that. So we've also discussed about, classification and regression. Now, how does classification work? We're talking about supervised classification. Is that you are going to have a labeled data. Maybe you want to classify between three things: a cat, a frog, and a dog. You're going to have pictures of cats, and you will type a text and say cat, pictures of dogs, dogs, pictures of frogs, frogs. You give it to the model with the labels, and then it will go through the features of the features in the pictures, and say, this is a cat, this is a dog, and it will output probabilities of them being cats and dogs. Do you understand? It's going to output probabilities of them being cats and dogs. Now, some of us are already familiar in Python. We already understand what I'm saying, right? Now, what does in classification? They can be binary classification, which is cat and dog. We're trying to find discrete pictures or features that is describing this is cat, this is dog. Cats are more feline. Dogs, their nose is different, their color, their eye is different. Cats are different, things like that. Multi-class means that, we're trying to say difference between, what can be multi-class? A lion, a tiger, and a jaguar, or a cat, a dog, and a frog. Yes, that's a good example. We are trying to separate features between more than two things. It's the same approach, right? But it's just more than two things. Now, this was the assignment from last week. Individuals' income. I noticed that the third point was not addressed by a lot of people, where you're supposed to take the prediction. You're now supposed to put a column to say rich, poor, rich, poor, rich, poor, rich, poor, rich, poor. Right? But we'll address that when we come to that. Now, we are moving into today's class. Now, today we want to try and achieve image classification with 9. And today we are going to go through an extremely long, unnecessary path. It's an extremely long, unnecessary path. First, to teach us the uses of some nodes. Second, to teach us some of the details or underlying details that has been covered by some libraries in the shortcuts, which we'll cover next week. Right? So it's very long, but stay with me and ask any questions you want. So this is image classification. This is somewhat of an introduction into computer vision, right? So we are going to do some level of binary image classification to distinguish between cats and dogs. You give it a picture of a cat, you give it a picture of a dog, and then you should be able to tell you that this is cat or this is a dog, right? And some of the data sets we are going to be using, we are going to move from iris, which is what we've done, to cat and dog, or dog versus cat, right? So now, given an image, what are the attributes of an image? An image can either be grayscale or RGB. What do I mean by that? When you look at your pictures, so wait, before I continue so far, any questions? Any questions? Any questions so far? Okay. No questions. So now, an image can be single channeled or multi-channeled. Now, when you take an image, right? When you take an image, if it is color, like all the image you post on, Instagram, all the image you post on Snapchat, scenery, all the filters, right? They're usually in colored images. And we also have some filters that will make them into black and white. Now, your colored images are known as, multi-channeled. They have 3 channels: the red channel, the green channel, the blue channel. That's why it's called RGB, right? Now, black and white images are known as gray-scaled images. Gray-scaled images. They just have one channel, black and white. Like, it's not black and white, one channel. It's just one full channel, black, white. or let's call it black, white, like. So there's no red, green, blue. It's just boom. All right. Now, in some technologies, wherever when you evolve out of this class and you want to deploy, sometimes some channels may be BGR instead of RGB, where instead of the red to come first, it will be the blue first, the green first, and the red last, or red, green, blue. So sometimes it is BGR, and sometimes it is what? RGB. That's just what it is saying. Now, those images, either RGB, BGR, or grayscale, those images are made up of pixels. They are pixelated. And those pixels are represented by numbers. Those pixels are represented by numbers. There's a numerical association of a color in computers. You understand? There's that's why it's computer vision. How does your computer see? So when you look at this color, this is the color of probably Abraham Lincoln. Now they've pixelated it. This pixelated image is now showing that this gray color on the spectrum of numbers, every color is made up from 0 to 256. Now on the spectrum of numbers, this color is 157, this color is this color is this. So when you give this array to your computer, this is how it, when you upload your picture, this is how your computer understands it. This is how your computer understands it. You understand? Black is totally 0. You understand? White, I think white is 256. So if you look at this 256, it is white, right? Or sorry, 255. It is white. So depending on spectrums, you can get different numbers. So, but in this picture of interest, this is a grayscale image. Any questions so far? No questions. Very good. Very good. Okay. Now, let's zone in into this image. This image is also a grayscale image. It's showing a picture of 8. Now, look at, one thing I want to tell you is, look at those numbers. If you look at these numbers, you can, if you look at it from afar, you can see the picture of 8, how it is written. The picture of 8, how it is written, right? You can see it, how it is written. But this is how your computer understands the pictures. Now, let me give you an example, right? Let me give you an example. Let's say I want to insert a text box in this, right? I've inserted a text box in this place. Let's say I want a picture. I want to fill it with a color. Now, just to show you an example that your color can be R, you can see it's RGB. This is, and because it is completely red, that's why green is 0, blue is 0, red is 255. If I want it to be completely black, everything will be 0, 0, 0. You can see the color right here. If I want it to be completely white, everything will be 255, 255, 255, right? Now, every color in an image is represented by a number in the, there's a number, a frame between 0 and 255. If I want it to be more blue or more green or more this, we can say that it's changing between the R, the G, and the B scale, right? This is in a 3-channeled image. Do you understand what I mean? So it is just to show you that colors and pixels or pictures or images are understood in the computer world as pixels, and those pixels are between numbers between 0 and 255. Any questions so far? Okay, I think I'm saying what we already know. That's fine. So that was my demo. Yay. Right? Now, what's the next thing? Once we pixelate the images, in many cases, in many scenarios, we need to flatten the layer. So just, I could not show it with an image. So just if you want to flatten this 8 image, it's going to be 0, 2, blah. Instead of it to be in a 2 by 2, in a square, in a box, in a square matrix, it's going to be in a straight line. We'll write all the numbers out in a line. We'll write all the numbers out in a line. So it will be 0, 2, 15, 0, blah, 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 blah. 0. Instead of it to come down, it will now be another 0, 0, 0, 4, 4, 4. It will be a straight line like that. So if we take this matrix for example, let's assume this is our box image. It is 1, 1, 0. Instead of it to come down, it will now continue as 4, 2, 1. And then to come down, and instead of it to come down, it will be 0, 2, 1. So imagine this image. So this image is a 28 by 28 image. I should be correct. 1, 2, 3, 4, 5, 6, 7, 10, 11, 12, 13, 14, 15, 16. This is the original is 28 by 28, 16. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 15, 16, 17, 18, 19, 20, 21, 22. So this is a 16 by 22 image. This is a 16 by 22 image. If I write it on a straight line, that means that the length of that line will be 16 times 22. Right? Any questions so far? Any questions so far? So it's flattened and we understand the concept of flattening. What do we do? Let's go over to 9. Let's go see this dramatize and become something that all this knowledge, kilowatt hour by. Let's go see it, right? I'm going to go to the meeting. Any questions? It's too quiet. It's too quiet. It's just too quiet. It's freaking me out. Josephine, are you there? Greg, you want to say something?
Yes, I'm just saying you're a very good teacher. That's all. Everything you're saying just makes
Thank you. Oh my God. I'm blushing. Thank you.
And let me add to that. We've not seen it practically, so that's why we don't have questions.
But are you sure, Josephine? Are you sure you are not just because you heard your name now? You now quickly unmute and organize and format yourself. You are listening. You are paying attention.
Yes, sir.
Okay, Esther.
Yes, sir.
No problem. Esther, unmute. I want to hear your voice. I want to know what you sound like. Esther, are you there? You can raise up your hand. Okay, some people have raised up their hands. Ismaila, allowed to talk. Thomas, allowed to talk. Ismaila, you can talk. Just unmute. Junior. Thomas, you guys can unmute. You raised up your hands.
Okay, yeah. So I want to know that how does first good afternoon or good evening wherever you are. I want to know how the computer differentiates between a grayscale image and an RGB image. Is there a way that you can differentiate that? Oh, this is a grayscale, or is it not related to this course, or is this something that is not related to 9 more? I just
by default, once it's one channel, it's grayscale. So many situations when we write the code, right, you can say, oh, I'm reading an image, and we will specify that, oh, this is grayscale. So for a lot of computer vision programs, we use OpenCV libraries. OpenCV will tell you it's grayscale or by default. Even by default, when you read it, it will just tell you that it's one channel and you can display the picture. So usually these libraries can adapt to know that this is a one-channeled image or multi-channeled image. Make sense?
Okay, so if it is a grayscale, it is one channel. Then if it's RGB, multi-channel.
It is multiple channels. So in RGB, you see the red channel, the green channel, the blue channel. Yeah.
Thank you.
Junior Allen. Junior, let's hear you.
Sir, so far I don't have any questions, sir.
What's pronounce your last name?
Mawunele.
That sounds powerful. Sir. Wow. Nice last name. Yeah.
Huh?
Okay. I said your last name is nice. You can mute. Let's hear from Ismaila.
Yeah, I've been saying this thing for
what have you been saying?
Hello?
Yeah, we can hear you now.
Yeah. I've been saying this 2 by 5, 6 by 2, 5 for a long time. The concept of flattening, I didn't, but now I think I can understand it very clearly.
We can't hear you. We can't hear you clearly. It's coming in and out. Okay, check on your audio and then let's talk. So let's head over to 9. Let's get our hands dirty. First things first, before we move, Josephine, I want to attend to your question. I'm going to attend to your question. Some people are not talking in this class. So Abim K, Adoga, if I don't call you, you don't call me. Folabi, Chioma, Emmanuel, Essie, Esther, Gabriel. Are we fighting? That people are keeping malice with me.
If we talk, we'll be disturbing now. So we don't want to talk too much.
Just raise up your hand. Let me see. You have not raised up your hand. Raise up your hand. Let me know that you are on the screen. I'm not talking to. Raise up your hand. Everybody has now raised up their hand. Oh yeah, wait, calm down. I'm not doing. All of you are not doing. So yeah, let's go to 9. Let's go to 9. Now, I'm going to address something that Josephine said. Josephine is saying that we are carrying expo. You know those invigilators that come. We are carrying expo. How can I believe that this is true intelligence? Right? That we are carrying expo. We are giving you the column and we are columning the column. But Josephine is missing a detail. Josephine say, Ashiri. I'm going to explain that Ashiri to you. But first things first, I'm going to use the class work to explain to us. So I'm going to drop this data set for us. So the first data set, we've worked on it before. We're going to use the iris data set. Iris data set. I'm coming over to the meeting. Where's the meeting? Here's the meeting. I'm going to the Q&A and I'll drop this link for us. Right? I'll drop this. That's where the name is. So, some people have dropped messages. Good evening. Thank you for amending about having issues. So this is Ogogo, you've been having issues. How to import the data set to 9. Took me a while before I got the link, but then I don't know how to import data set to 9. Ogogo, is it possible to how do I install the display console? Who is this? Gabriel. Please, do we have recording? Yes, we do. So Ogogo, you've not watched any of the video here. I'm going to show you how to put data in. How do I install the display console? Just go to the 9 link. You'll get it. So now let's download the iris data set. This is the iris data set. We've tried it before. It has an ID, sepal length. We're not going to go into details. Let's download it because we've done it before, right? We've done it before. Archive 42. So we come to 9. We know that the file, we know that the data set is a CSV. We know that the data set is a CSV file because they're using it that it's a CSV file. So what do we need? What do we need? So what do we need? We need a CSV reader, right? So Ogogo, how do you put the data set in there? We've downloaded a new data. We want to find the data. We'll come to CSV reader. We will click on configure. When we click on configure, we'll go to browse. When we go to browse, I just downloaded it, so it will be in my downloads, right? It will be part of the freshest things that just came in. I'm looking for a CSV. It has seen iris.csv and it will open it and bam, I have imported the data set. Apply, okay. And then I will run it. I know we are already familiar with this, right? And then I will run it. So this is the data set. Now, what's this data set telling me? This data set is a classification data set. It's a classification data set where the features of the image, they've specifically picked some features of the image, and it is the length, the width, the sepal length, sepal width, petal length, petal width, and they want to classify 3 species of flowers: setosa, versicolor, and virginica. Right? We've done it before. So what do we do usually? Right? I'm not going to go through a lot of this. What do? We would what? We would normalize. No, sorry. Let's just do, we will partition, right? We'll partition into test and train, configure this, partition into test and train. When we partition into test and train, what do we do next? We will take a logistic regression and a logistic regression learner. We will take this, what? No, we'll take this here and we'll pass this here, right? Of course, this is not standard practice. I will have done a normalizer. I'll have done different pre-processing, right? But I just want us to. So when we take this here now, Josephine, this is where I will answer your question. You asked the question. You asked that we are giving everything to the learner. But as we are giving everything to the learner, how does it know what we are doing? Now, let's go back to the data set. This is the data set. If you see, the data set has how many columns? 1, 2, 3, 4, 5, 6. 6. Now, this column, it is irrelevant because this column is just saying ID. It's irrelevant. So, the features that we want to use is 1, 2, 3, 4. The target is what? Specie. Now, if you come to this logistic learner, if you see, they've told you here that the target, can you target? Josephine, on mute, tell me, what's the target? Species. You can see it in this column, species. Now, you can see this column is useless. We are going to take it out. Useless. Now, 1, 2, 3, 4. So what we are telling the learner, we are telling the learner that use this 4 to train for this target. So in the code, it already knows that this is what I will use and this is what I will take out. Am I making sense? Have I cleared your doubts?
Yes, sir. Yes, sir.
It makes sense? Good. Now,
Yes,
when
sir.
I do this, right, and I train, bam, it has trained, right? And I take these lessons learned to this person. Let's come to this Cohort. Right? Now, this one, if you notice, look at what he did. Look at what he did. It already knows what this one, the configurations, this one, all the configurations here, it is transferring it. So when it wants, even though we are giving it the whole column, it will first use this, it will look for all these features and use it to classify. And it will create it, it will use it to classify and create a new column called, you can see it, ordinary zone, it will create prediction specie. Prediction specie. I didn't tell it anything. It already knows that it has to predict and it has to predict specie. Or species, sorry, species. Am I making sense? Josephine?
Yes, sir. You're making sense, sir.
Okay, and then let's do this. So this one, species, prediction species, this, and then boom. And we can see this. But all these ones has error because, you know, we don't have some things, right? Any questions so far?
I just had something to say about that because actually I had a similar situation where my predictions were like all ones and zeros, and what happened was it wasn't the inclusion criteria, it was the scorer. So I said like the configuration was wrong, so I had the prediction value in both.
Oh yes, there are situations where you do this.
My
Yeah.
actual category. So
Yes.
it has to be species and prediction species in the other one.
Yes.
So
There are situations where your scorer is wrong. Thank you for that, Joy. There are situations, let's reset. There are situations. So in this situation, you are comparing prediction with itself. So it will tell you that it's perfect. Are you sure this is not what you did? So in this situation, it's telling me that it can't be this. Some people are messaging me. Some people are saying that they are saying that just give me Okay. Hold on, sorry. Try this. Okay, so Folabi, some people are raising up their hands. Folabi and Ogogo, yes. Yes, nobody's talking. Folabi, Ogogo, Francis. Okay, if in the absence of nothing to say, Folabi, Ogogo, okay. Okay, okay. Oh, yeah, talk. Okay. Yeah, put your hand down. Okay. So now we know. So Josephine, I've cleared your doubts. Now let's go into image classification and why do I think they are very closely related. Let's take this. Let's go there. Let's go there. Now we have cat, we have dog data sets. Images. What type of data are they? They are what? They are what? .png. So we have .png images, so they are actual images. It's not .csv, they are images. Let's download them. Please, any questions so far? We're downloading the images. Any questions so far? Abimke, Adebayo, Adoga, Folabi, Anjorin. You've not joined this meeting in a while. Anjorin. Anjorin, with the way you are doing. Chioma, Damilola, Emmanuel, Esther, Fumi, please. So
I have a question.
You have a
It was
question?
kind of related. Someone had a question about the CSV reader. If we have multiple files that we want to train, is there a node that we can use to do that, or does CSV reader do that as well?
Multiple CSVs, if I may ask.
Yeah, multiple data sets, yeah.
Okay, I will attend to that now. Folabi? Folabi Shailon. Hello, Folabi.
Can you hear me?
Yes, we can hear you, finally.
My question is, why are we using logistic regression this time around? Is there any reason? Because we are used to linear regression. Is it because we are dealing with images? Is that the reason why we are using logistic regression? That's my question.
Folabi, I when you don't ask question, I'm worried. This is a very good question. I don't know why nobody asked. But let me answer it. I'm actually supposed to have tackled it. Adoga, what's your question? You raised up your hand?
No. Sorry. I was filling the question and I was like, oh, you've explained this before, boss. Sorry.
No, yeah, fine. So now let's go. Now, logistic regression. Why did I use logistic regression? Now, I'm going to do something. Now. Let's do linear. You know the beautiful thing about 9, you can try many strategies. I'm going to take this and give it to linear regression. I'm going to take this and give it to linear regression. See what linear regression will do. Did it train? See what linear regression. You can see what linear regression did. Linear regression took petals. Now you can see as a target, linear regression will not bring out specie. You know, I'm trying to predict specie, right? Linear regression cannot work on a linear regression node, cannot work on a non-numerical feature. Linear regression cannot work on a non-numerical feature. Am I making sense? Linear regression, so because the feature I'm trying to predict here is in words, is a string. If I come to statistics, it's a string. It's a problem. But last week, I used linear regression to do this. But let me show you how. What will I do? I'll come to category category to numbers. So I'll just take this. I'll delete this. I'll take category to numbers. I'll run it. Now, if you look at category to numbers, species, it has done species to what? Number. Ashiri. It has turned species to what? Number. Then when I take it here and I configure, see what I can now see species to number. I will now take ID out. Species, it will not use species, but I'll take it out because it's useless. I'll use the 4. I will apply it. Bang, 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 bang. Abikoti training. It has trained, right? And then I'll use my regression predictor, right? Category to number apply. I'll take this, I'll take this, I'll take this one. So the beautiful thing about NIME is you can do a lot of strategies together. I hope everybody understand what I'm doing. I know I'm moving very fast, but because we have a lot of things to, and then we will use numeric scorer, right? By the time I run this, and I run this, and I run this, and I do this prediction, yeah. It's a big bag. Hold on. So yeah, species to number is here. I come here. Number is category to number apply that I'm supposed to use. And then this, I use number to category. Yep. And then this goes good. So this is just in a quick way, species to number. So you compare species to number and then perfect. And then this will give you your own regressive score. Please, if you go through the examples, you can see the same approach. We've tried different strategies. So, but let's continue. Folabi, I hope we are good now. Okay, no questions. Yes. So
Yes, boss.
yes, very good. Now let's go to images, image classification, image binary classification. Let's train cat versus dog. Any questions?
So it's the link to the data set for the cat and dog.
The link to the data set for the cat and dog. Control A, Control C. We're still recording here. We're recording. Okay. So I've sent the link to the data set for the cat and dog. Please come here recording. I missed first class and having something understanding it. Where do you find browse? I'm glad you have recording. All tabs. Nope. Broadcast. Oh, okay. So yes, there's recording in the classroom link. In the classroom link, we can send that to everyone. So but let's just because we have a lot to cover and we have less than an hour to do it. I want us to be done in an hour. So yes, we want to do image classification. This is another realm. Please pay attention. Now we are going to read from a folder, right? We're going to read from a folder. Please, this is it. This is it. It will come out as animal. Animal, this is dog, and this is cat, right? We're going to read from a folder. So now, let's come here. We're going to come to lists, files, and folder. Because we are reading files, picture files from folders. We'll come here. Now, we want files in folder. I will browse to my downloads, and then I'll look for the most recent file. Okay. Animal, and I will choose. Right? I will apply and I will say okay. And did you see what I did? I chose browse to that file and I ran it. Right? I ran it. Now, in 9, you can only work with strings. So we have taken a path. Now we want to use path to strings. Just hold on, coming. Sorry. So files in folder include subfolders. You can see it. When I did not click it, it just said no files matches these criteria. But if I go to the subfolders, you can see that it has selected 1,000 of 1,000 files. And if you look at our data set, there are 500. Where is it? Where is the data set? There are 500 images. Total images is 1,500 for cats, 500 for dogs. So you can see that it's aligning. Now there are 100,000. So this, I'll re-execute and I will go. So it will include everything and I will run. And see what it has given me. It has given me cat. And then it has given me, if you go down, dog. So that means that the first 500 is cats. Abby. The first 500 is cats, and the second from the second 500 is what? Dog. Any questions? Any questions? Okay, good. I think we are good. Right? First 500 and second 500. Now, but this is a path. You can see it. It's a path. We cannot, in 9, we cannot work with path. It's a directory. We can only work with what? Strings. So we are going to come with something called path to string. So we'll take it. Every path you see, convert it to a string. It will create another one. Now, path of data type path is now location of data type string. Am I making sense? Am I making sense? Okay. I know. Now, what's the next thing we want to do? We want to read the images. We want to read, so we are going to come to an image reader. Image what? Reader. The image reader will read the string and know it's a path and read the images. And what do we have? You can see it's reading the image. 10, 15. So while it is loading, any questions? Anjorin, say something. I want to hear your voice. Anjorin, raise up your hand and say something. Anjorin is not on this call. You just sat down. Some of you are using me to watch Premiership. Olaleye Dorego. Is it Dorgos or Dor? Olaleye, come on, raise up your hand, correct me. Bankole, Richard, any questions, please? And Johnny, you are raising up your hand. You can talk. Adoga, yeah. And Johnny, yeah.
Yes, sorry, sir. In fact, I'm just entering. I've been in a very busy road. When you called my name the last time, I was at a very rough bus stop, so I would disturb the class. So I said, let me get home before I'm able to comment.
Oh yeah, get home now. Wash your face. On your laptop.
No.
Class. Huh?
Yes, I'm with you.
Okay. Yeah, with your laptop,
Not yet.
No problem. We hope you are going through the classes and everything, right?
Yes, sir.
Okay. Adoga, you raised up your hand.
I can't find the image reader node.
You can't find it. Where did you put it? You have misplaced
it. You use image reader node, and I can't see that. I'm seeing the read images.
Did you when you installed it, did you go to preferences and you say 9 modem, you clicked on all nodes?
I did.
You did, okay. Okay. Now you come to image reader table. That's how it is. Image reader table. You can search it. Image reader table. Have you seen it?
No.
Check your preferences.
Okay.
Is it just him? Is anybody having that problem?
All nodes, yes. I'm on all nodes.
Is it just is there any other person that is having the same problem? Because it may be a situation where you are trying to, let me see, image have installed. Let me see. You may need to install image processing. Yeah. You may need to, install image processing. Let me go to, or you may need to install a node. So these are some of the nodes I have installed. So you can see there's image processing, deep learning extension, image processing. So you might need to install some image processing nodes if you are not getting it. But I assume you should be able to get it because I've not told anybody to install extension and nobody has complained. Unless nobody is doing it and it's just you.
So it's also not showing for me too. I can't find it here.
Who is saying?
It's me.
I can't.
So I think there's an extension you need to install that will bring it out for you. So
the image processing, right?
Yes. So we'll come to image reader table. Let me get the extension table. Not in name. Not in name. Image table node. So blah blah blah. I think it came by default.
It's a 9 image processing. You need to download that.
Yeah, you need to install the extension of 9 image processing. Yes. So once you do, so just come to you may need to restart your 9, but once you come to menu, install the extension, it won't show for me, but it's 9 image processing. And then it will tell you to install, and then you install, right? So you just click everything and then you install, right? So that's that. So we have read the table and we have seen the images for those that like cats, How many people here like cats? Me, I'm not really a cat person, but some people like cats. So image reader. Okay. Now, look at these images, right? Statistics is telling us that it's 1,000, blah, 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 right? Now, for the sake of time, if we decide to use the full size of the image, it will take us, a long time to get it. So I'm going to resize the image. Image what? Resizer. I'm going to resize the image. Now, depending on the scale, so this image is saying that you're using 1:1:1 scale, right? You're using 1:1 scale, right? If I want absolute image size, you can't change it, right? Or image calibration. But this is just saying that you want to use the full size of the images, right? Don't know why this is saying it can't change, but let's run it. So you can see that because we are dealing with images, and you can see how slow it is. You can see how slow it is because images are much more powerful. Images are a set of matrices. And please, I'm going to call someone randomly. Thank God, I have a question now. Who is there? Who is there? Chioma Ebe. Chioma, are you there? You can talk if you are there. Chioma. Chioma, are you there? Okay. Chioma, who can I call? Okay. Fumi, are you there? No. Gabriel, let's talk. Gabriel, I want you to look at this image. Tell me, is this a grayscale image or a RGB image or a RGB image? What type of image is it? The image you are looking at. Is it grayscale or RGB? They're not answering me. Greg, you can speak.
RGB.
It's RGB. Ah! It's RGB. Thank you. So if you don't understand why it's RGB, you can raise up your hand though. Does everybody understand why it's RGB? Muyiwa, Kenneth. Sumbo, you didn't join the class. You now snuck into the class 2 minutes ago. Sumbo, I wrote your name down. And Johnny, please, you can speak.
So it looked more like grayscale to me.
Why? Why is it
As in,
grayscale? Do they look
I
like
think
black
it's because you
do
click on
they
it.
look like black and white images?
No,
okay,
actually, when
now,
you click the first one, it looked, and the icon is there. It looked like a gray screen. But when you removed it, and I saw that it had some colors on it.
So these are the images, right? You know, normally, if not because if it's because we're pressed for time. These are the images we would have. Oh no, what the hell? Animal 2, cats, and then this. So these are the images. It's because we are pressed for time. That's why we are going in this way. But if you look at them, are they black and white?
No.
No, they are colored images.
Okay.
And because they are colored images, right? Hence they are what? Black and what? And they are RGB images. I know some of the people they'll be like that on me to be like, so cute. Don't listen. Yeah, don't listen. Any other questions? Sumbo, I'm still waiting for you to talk. Oh, okay. Sumbo is not talking. It's fine. Yep, I think we're good. Good. So with this time, it is already done. So we can resize the image. I'm coming. There should be a way to. And if you want to change the scale, like if you want to change the scale and say, I don't want a scale of 1 to 1. I want a scale of, you know that one, that luminance image that was 16 by 22. That means they scaled down the width, they scaled up the height. We can say 0.19. Right? You can scale it by the axis. So, of course, 0.19.
So why does it say one channel if it's RGB?
Now, please hold on. You can see that when I did 0.19, 0.19, 0.9, you can see how fast it went compared to when it was 1. Where did you see one channel? Hello?
Right next to the XYZ that you just adjusted, it says channel.
So I would say channel here is not necessarily the channel we mean, right? This channel does not mean this channel is another configuration from 9. The channel we mean is different. This is just a general configuration from 9. So far, I have not played with the channel here, but this does not mean that this is not. This does not mean that the images that we are currently reading is grayscale. They are RGB images. Make sense? To answer your question, I don't know what this channel configuration means for now on 9, but this, and also the images has length and breadth, but it's just saying the scale across all directions. You understand what I mean? So, but I can get back to you on that one. Right. So you can see that when I scaled it down to 0.19, it scaled faster. So we'll use 0.19 scale for the sake of this class, because when you go through the learning, when you go through the this and the that, the training across those huge picture, it will take a long time, right? So we're going to do that. All right. So now this is the image resizer. Now, this is where we will now see similarity between this and Iris data set, the one we did here. Now I'm going to come to image to data. What does this mean? Image to what? Data row, right? When I click on it, what did it do? It converted all the images to numbers. All the images we were seeing here, they have now been converted to their pixelated numbers. Am I making sense? So that pixel, and not just pixels, they've been flattened. They've been what? Flattened. Hello? Are we there? Is anybody there? So you understand the concept that we said. They've been converted to pixels and they've been flattened. So that's why we see a straight line. Then the next thing is this. You can see that. Let's go to the statistics. See, it's even nothing. We can't just use this data. We can't just use, so we are going to split. You can see it's a row. We are going to split the data. So we would come to split to what? Split collection. Right? I'm going to split it. So what does it look like? Now you will see the column. The column will be long. Now it has taken this image. So you can see 167. It has created a column called 167. 50, 50, 53, 53, 45. It is all boom. You can see it. It is a very long amount of features. So this is the flattened picture. You can see it is so long, it skipped the remaining columns. It is so long, it skipped the remaining what? Columns. Am I making sense? What did I first do? I read the folder or locations of the files. Then I converted those locations to strings. And then I read all those strings, because it only reads strings, to the location to read the images. Then I resized the images because of processing time. So whatever was big is smaller and less pixels. And then I converted the picture into their pixel values in a flattened manner. Then those flattened manner, you know, these features here, if you look at these features here, you can consider them as features of the flower in a flattened manner. But they are just 4 features, right? In a flattened manner. In this scenario too, we are taking it, but now it has flattened it, but it's a list. You can see it, image, list. It has written it as a list. We want the list. We want to slice each list into a feature, and that is what we have done. Any questions? Thank you. Since that is good, we split. Then what can we do? Remember that when we were here, we did not tell that this is a cat. We did not label the image. We did not tell that this is a cat. In this place too, we did not say that this is a cat. We did not say anything. So it doesn't know if it's a cat or it's a dog. We now need to add a cat and a dog. We will come to our rule engine. Now, when we were checking it, we noticed that the first 500 images are what? Are cats. And the second 500 images are what? Are dogs. So what will I say? I will say that, for the row, if it is less than or equal to 500, let it say it's a what? It's a cat. And if it is what? Greater than what? 500, let it say it's a what? It's a dog. Right? And label it prediction. Am I making sense? Of course, we cannot see the end. We cannot see the end. We cannot see because it's too long. We can't see the end, right? We can't see the end. So this is what I will use for you. I will advise for you to use to monitor. So let's say column filter. I want to see maybe these are all the features. All the features. I want to see, you can see they are very long. All the features. In short, you have 28,227 features. 28,227 features. So I want to see maybe the last 5 features. I want to use this to monitor. I want to see the last 5 features. I'll just run this and I'll look at it. So you can see it. It's saying cat. So this is the last 5 of the column. Cat. And what? Dog. Any questions so far? You can see I've labeled the images. Any questions so far? Okay, no problem. So this one, we'll just be using it to take around and to be checking. Now, we can also come and configure. So since we've inspected, send everything out, send everything back. We don't need the image anymore. We don't need the image anymore. It's useless to us, right? We already have all the features like this, and we have prediction like this. Okay. So we have separated the image. Bam. Then what's the next thing? The next thing is it's now to train. We already have features. It's just like we now have Setosa. We have features. What do we want to do? We can decide that, hey, we want to partition into train and test. We want to partition. When we partition, we want to normalize. So we want to partition 70%. Okay. Right. Then we want to what? Normalize. So from all this place, normalize, we will normalize, and then this, now the model may not even be good, and then normalizer, apply, normalizer, apply. You can see how, no, in short, before we normalize, let's just train. Let's just see what we have. Right? So logistic. Now, why am I using logistic regression? Because I still have cat and dog there. If I switch it to use category to number, I can switch it to a number and also use it. So logistic regression will go. You can see it's taking its time. And then we'll use the regression learner. Right? You can see how it's taking its time because it's a lot of data. Regression learner.
To clarify, you use logistic regression when the predictor variable is a categorical variable.
Yes.
Because every
it can be, it can be categorical, and it can be numerically categorical. You can also use linear regression there. Right?
Right. Linear when it's a number and logistic when it's not.
When it's a string.
Okay.
Right? So, and then we'll come. You can see there's an error. There's an error. It's saying that the Java heap space. So that means that we have configured a lot of files and blah, blah, blah. We need to do something about it. Not to worry. Let's do something about it. Come to name, come to this, come to this. And now when you have this, you can, switch it and say 16, and then save, and then that, and then let's try again. Oh, no, it was still cut. Sorry. I need to close 9. Sorry, I made a configuration, a NIME configuration change because of the error. It's saying there's a space issue, so I increase the space or the Java 8 space of my NIME on my system. So that's why. So, and for that to take effect, I need to restart my NIME. Am I making sense? Hello? So while all that is going on, yes. Are we excited that we can now do image recognition on 9? Everybody, people are quiet. Richard, I don't know what you sound like. Obinna, Francis, Sumbo, Olanrewaju Adegoke, Olaleye Dorgos, Muyiwa Kenneth, Ismaila. Some people raising up their hand. Fumi Lancer. It's taking longer. Yeah. Let's be patient. I'm not that patient. Yep. So this is going. Yep. It's loading. Let's see if we've not lost all our information. So it's loading the workflow. It's loading the workflow. So this to show you that the computer, the computer or memory requirement for computer vision is a different ball game than when dealing with numbers, right? The cost of training images, and some people they now do video processing. That's why you do a lot of GPUs to train images, a huge size of data centers. Now imagine this is just 1,000 images of a cat and dog. Imagine what they're using to train ChatGPT, right? So that's why it takes ages. Let's see. I don't know why it's taking this long. It doesn't take this long with me. But so far, I think to where we have reached, everybody can go on their own and do logistic classification. You partition it, you do logistic classification, then you find the scorer so that you can see the confusion matrix. Any questions?
So, but I'm a little confused with just plain old logistic regression and what you were calling classification regression. Like, what is the difference between that and what you did last week, where you did both?
I did both. So what I did last week was I would convert. So I would do logistic regression as is by default. When I do that, I will then I will do logistic regression, find the scorer, and that already exists. Then I will now take that feature that is cat or dog, I will then I will use category. I will convert those features to numbers. I'll convert those features to numbers. And once I convert it to numbers, I will now do linear regression on them. When the output comes back, whatever the output comes back, because it will predict it as numbers, I will use a rule engine to make those numbers predicted into something called into category, and I'll now print another, confusion matrix based on linear regression. Does that make sense? Did I speak too fast?
It makes sense, but it's also very confusing.
So look at. I think we have it here. I think I lost all my previous files. So look at, where is it? Oof. Eesh, I lost a lot of files. Yeah. So yes, just to answer you, let me see. So this is what I did. I did logistic regression. Logistic regression. This is the default, because we are dealing with non-numerical variables, right? Now, what did I do? I used category to number to convert it to numbers. Then after training, in this place, this is the prediction. The prediction will also be numerical. The prediction will also be numerical, right? Am I making sense so far? Now, if the prediction is numerical, I can now use a rule engine. So what I did last week was I used a rule engine. I used the rule engine to say, hey, hold on. This is between 0 and 0, 1, 2, right? 0, 1, 2. So I use the rule engine to say, hey, if this is less than or equal to 0.5, say it is, if you remember,
Yeah, I remember you gave it a range, and it was basically like you were
given a
including.
range, and that range now made it into words again, and then I compared it, and it gave us 100% accuracy, if you remember. So I have used regression, but I've now used a rule to convert that regression into classification that I can find a confusion matrix out of. So that's why it's regressive classification. Does that make sense?
Right. So when you converted it to the categories, you then did what on it? So you initially did linear regression, and then you got the predictor numbers, and then you converted it to categorical, and then you did logistic.
So
So
I
what was it
didn't do logistic any longer. So if you look at regressive calculation, can only work with numeric scorer. Logistic will work with scorer. So I'm going to take this now. So this is, let's say this is the result. This is the result of my linear regression. But I want to add a classification piece on top, right? So the classification piece will say, oh, take this. If it is less than or equal to 0.5, say it is, Iris Setosan, right? And then I will put another rule. So if it is less than or equal to 0.5 is this. If it is less than or equal to, 1.5, if it is greater than 1.5, I think one is Virginica, and then vertical, right? So going to do that now. So 0 was Setosa, so you can see, oh, versicolor, versicolor, right? So versicolor and Virginica. Now this has created another prediction. This prediction came from this place, from this number, not from this. So I'm going to compare this prediction with this species. I'm going to compare prediction with species, but what regression compared this species with this prediction. So if I come here and I take, scorer, right? And I say, oh, take scorer. Scorer is going to ask me, what are the two things you want to compare? Species and prediction. And then instead of it to give me a numerical what, it's going to give me, bloody, I got some spellings wrong. That's why. So,
But I think I get the gist of it.
so there's Virginica. Is it to V? Okay. Capital letter, capital letter, capital letter, small letter, small letter, small letter. Okay. Okay. So it's basically you apply class to some categories and then boom.
But it's almost it seems like you're basically just you're basically encoding the previous prediction.
And
Isn't
this is
that what you're doing?
so what did you say?
You're basically encoding the previous prediction. So the previous prediction that you got from
Yes,
the
I'm now encoding it to the
you're
original
setting it
category.
the
Yes,
label, and then you're comparing the label to
the prediction, the encoded prediction. Make sense?
yeah.
Yeah.
Okay.
So if you look at logistic regression, if you look at the accuracy, it's about 93%. If I come to this one that I've added a layer of, if you look at the accuracy, 100%. So there are different strategies you can combine. But if you look at the result of the regressor, the result, where is the okay? The result of the regressor, oh wow, is even perfect. Okay. The error is 0. So some at the big mag is somewhere, right? Let me look at this species to number. Yeah. Let's take this out. ID is useless. Okay. So I think we're back. What's the time? We have 30 minutes.
Okay. I mean, I think I get it. I don't want to keep the class.
So
being-
yes, we missed one. The accuracy is 97%. 97%. The accuracy of this, okay. It is approximately 0. It's not totally 0, but this was 97% compared to 93%. So yes, sorry about my system. It lost juice. Oof. So everything I was doing in the class has been, it got away. So since we already know, and please let me know if there's anything you don't understand from previous.
Please, what you are doing, can you do it slowly so that I can follow along, please?
I'm doing.
Thank you.
No, there's a recording that you can even play at
You
0.5.
you don't put stop until Friday.
Oh, well, don't worry. It's because I'm going to put it immediately. I promise you. I'm going to put it immediately. You people have already given me bad name. I don't put stuff until Friday.
Hello, sir.
Yes, please.
The fact that your system lost data, it didn't maybe save or whatever.
Yeah.
I was just trying to think what lessons can we learn from that. Does it mean as we are doing ours, is there a way to save it up so that we don't? What lessons can we learn from that?
No, it's because I forced. If you notice, today we've not even worked on this, right? The iris data is saved. It saved everything, and I could just come back and say, "Oh, what is here?" It saved everything, right? This is data that we've worked on 2 weeks ago. So what happened was I forced quit when I forced quit this 9. That's why it lost the data.
Okay.
It was because of my impatience. That's why.
Okay. All right.
No problem.
But did you save it before you?
So 9 auto-saves. I actually saved it. It brought out a notification to save workspace. I did. It was taking too long saving, then I forced quit it.
Okay.
Make sense?
Yeah, that makes sense.
So image resizer, then we come to what happened? Where is it? Data flow. From data flow, we'll come to column something. What's the name?
Column filter.
Column. Yep. And then from there, we stop that partition. And then we'll come here. We'll include subfolders. We'll browse. We'll go to downloads. And then we'll click 1 and 2. And then we'll click this. And then we'll choose.
I think you've missed one or split collection column.
Yeah, it's here. It's here.
Okay.
People are paying attention. Somebody's not paying attention. That I know. So, Mogumagi. Stop, reset. Let me come to this one and say 0.19. Some people do not ask me, why am I using 0.19? I'm not going to answer it. If I ask the question, I'm not going to answer it. They ask me.
We're
Ask
using
me now.
0.1.
It's too late.
Please tell us, please.
So I tried different numbers. You can use as low as 0.1, but in some cases 0.1 is too small, right? It's too small. So 0.9 was the one that 0.19 was the numbers I played with that was small but still showed the pictures. That's why. It's not a big deal. So it's moving fast.
Thank you.
You're welcome. And then wait, let's try this. Let's try 20% so we can at least see. Okay. And then we come to logistic regression. And then voila. And then we'll come tapping. Oh, sure, you see what I did. We'll come here, we'll say rule engine. The rule engine to label, you can see logistic regression complaint that all the features is looking at numerical. We need to give it non-numerical, right? So we'll come here and say if row index less than or equal to 500, right? Make it a cat or make it a dog. And then run it, and then we'll send it. We'll go to partition.
You should check that logic. I don't think you got the
Which one?
The
rule
one, I
engine.
think. Yeah.
The rule engine. Okay. This logic. Thank you.
Right.
Greater than 500. Yep. Okay. This goes, and then we want to use 20% so we can quickly train. Okay. I think we're back to where we stopped. And then, sure you see, it's because we're rushing. A column filter. We want to use a column filter. Why do we want to use a column filter? Because we want to remove image. All right. Okay. And then this will come.
What is image? What column is image?
Image is the actual image itself. We don't need it because we've already gotten the features of it, right? So if you come here, the first column is the matrix, but this matrix will split it into different stuff. So we don't need this. right?
Okay.
Am I making sense? So that's why.
Mhm.
And then let's go. So this usually takes a long time. So, and then we'll take regression learner. Logistic regression learner. Yep. Now I'm going to do something just so partitioning. I'm going to use a partition so that the remaining, I use 20%. That 20%, I also want to use 20% of that remaining 80%. 20% so that we don't fall into that. And this 20% will come here. This learning will come here, and then we'll come to a scorer. And then that goes there. And voila, we've been able to write a machine learning. Now, we've not used normalizer. We can also take this and use one category to many nodes and convert all those cat and dog to 0 and 1, use linear regression, do that. You understand? We've not done that, but you understand? Those are things we can do. So this will take a while and everything, right? So cute. Cute and
Why did you do the multiple partitioning?
just to save time. I did this is 20%, so that means 80% will come here. So I just did another 20%, so that it doesn't crash and we finish on time. Do you understand? So I partitioned. So this was 20%. This is 80%. Out of that 80%, I'm using another 20% for this classification.
Okay.
So, and on today's note, hence my story, right? Now we took this long journey. This is a very long journey because I wanted to show you how to read from folders, files from folders, how to read images, how to do images. There are other image nodes. You can crop images, you can extract features, image generator, different things that we've not used, labeling images. There are some other things you can write to image vectors. So this is just to show you that we can use this node. This is what this node is. This, in case there are problems you face, that will require those nodes, so you can know that, oh, this node exists, this node exists, this node exists. Does that make sense? So next week we can see how we can use deep learning libraries. Now that would be a bit challenging. Apparently 9 for my computer, 9 has an issue with M1 Apple chips. So I will show the frame, but people on Windows will be able to do it. People on Apple Intel chips will be able to do it. I will show the Windows, I will show the flow, I will explain the flow, but I will not be able to run it because of the complexity of my computer. But it won't have a lot of all these, so it's going to be, we're going to move into deep learning. Make sense? That being said, any questions? Ayobami.
Sir, is it safe to say that the column filter is doing the work of the CSV reader? Because after we have gone through all the process of image to data row to split collection and things like that, the final place we got to was the column filter, and that's where we actually need the numbers, and that's where we start doing the partitioning. So can we say the column filter, is it safe to say the column filter is doing the work of the CSV reader?
No, it is not. It is not safe to say it. Now, the role of a CSV reader is to go to folders and read CSV. Is to go to what? Folders and read CSV. The role of a column filter, is to tell us that, from this place, these are the columns I want to pass through. These are the columns I don't want to pass through. Do you understand? So different exercises will require different nodes and even different applications of nodes. So the column filter here, the role is playing is that we don't want to give the learner too much unnecessary things. So let me give you an example. If you look at this, right? There are how many rows? There is one image, and this image is now a list. 28,000 columns. 28,000 columns. What if I want to remove 14,000? So the image, the learner already has 28 things to learn. I want to remove one of them. That's what the column filter does.
Chief.
You understand? It can remove all these columns. That's all it does. So that we don't have excess things. So some of you, right? If you want to, if you want to be very, if you want to be very, very adventurous, which I know all of you people have already, you cannot come and say, I did it. You can use a row filter. You short your assignment. Go and learn how to use row filter. You can use a row filter to separate the rows, slice the rows into half and see if it is able to identify. So when I mean slice the row into half, if the row is maybe from here to here, slice it into half. When you slice it into half, no. So the row is one image. Slice the column into half. So in this column filter now, we can decide to say, everything should get out. And I only want half of it. I only want anything with split 1 to 500. It's 1 to 14,000, right? I only want half. You can see 28 of 28,229. I only want half of it, half of the features. Let's see if it will classify well, right? Instead of 28,000, you can see it's even stuck at 31%. Let's see. How will I? I'm trying to see how to, how to take all of them. Let me take all of them like this. And just do, so I can say the first 100. The first 100 will not do jack shit, right? Let's say the first 1,000. Right? So you can see that it's taking time with the first, this. So let's do this. Okay. I'm going to cancel this. Command or crash. You understand? So now, do you understand what I mean? So you can experiment with a lot. This is where, someone should give me this technology now and say, it took 28,000 variables. My accuracy is 99%. Someone should now come, it took 14,000, which is 50% less. And my accuracy is maybe 95%. Which one will I pick? I'll pick the 95% because you are saving me 50% resources and you're just compromising with 4% accuracy. That's fine. So this is where you now are adventurous. You can use different column filters. You can use different row filters. You can use different things and see if your model will be better. Am I making sense?
Yes, you are.
So I'll send this back. So I send the first 500 and something features, and then the others. Okay. But it's not answering because this is loading. Right? I've clicked cancel. If I'm trying to delete it, it's not deleting. So, but just try it on your own at home. Let's see what the results will be like. Ayobami. Okay, yeah, don't talk. Yeah.
Hello. Please, my question is, why do you use the two partitioning? Does it mean we are losing some data? Some data we are not even considering some data at all?
Very good question. Let me bully somebody. Ogogo, I want you to answer the question. Francis, I want to see if you understand. Answer the question. Who will answer Ayobami? Joy, can you answer Ayobami?
What was the question? Sorry.
The question was, when we partitioned, we put some variables to train. That means we did not even take into consideration some other variables. Hence, why do we partition?
I think it's intentional that we separate some from the others because we train with some, and then we use the data that wasn't trained to test if our training model, if the model that we got from the training data works, basically. So we want a separate data set that the model hasn't seen to test that the model works accurately.
Okay. Ayobami, I'll still come back to answer it too. Adoga, you raised up your hand. Oh yeah, Adoga. Adoga. Answer the question. Adoga, yeah, you know you can talk. Okay.
Sorry.
Yeah.
Can you hear me?
Yes, I can hear you.
Okay, lovely. So the like you said, the first set, partition means place it to. The first set, you take it as use it to train the data, use it to teach the students. Then the next set is what you give it as exam based on what you've trained it.
Okay.
In addition to what has been said, I think when you admit a student, you don't just administer exams straight away. You test them first before you give them exams. So that's why we partition into two sets so that we can test with the other one later on.
Okay.
But the essence of partitioning is just to separate the data you want to use for training and the one you want to use for test. But we went again to partition.
I get you.
We went again to partition the test. Then that means we are losing some. Fraction of.
So when you are doing your own, don't partition like that. Why I partitioned like that was because this was taking a long time. It's
too
because
more time.
Yes, that's
because
why.
We've cut off some data.
When I'm going to train, I'm not going to use this one at all. I'm going to delete this one. It's just because I wanted to use small fractions of the data, save time. This exercise. Okay, makes sense. Now, yes, again. Yes,
when I was doing the adult data, I realized that we are given two sets of data, the train and the test. So there's no point partitioning.
You were given the train and the tests in the data set, right?
Data set, yes. So there's no point partitioning again. So I now find it difficult to how do I combine the thing. I just got lost somehow because the data set has already been separated to train and test. So I don't see any need for me to partition. That means they want me to use those data direct. But combining the two now, I was some kind of lost. So I don't know whether you can.
Yes. When you are training, you split your data into three. I know we've not gotten there. You split it into three. You split into training, validation, and testing data sets. Into training, validation, and testing data sets. Now, beautiful for them In this, what is that adult? I opened it now. In this one, they've given us the training and they've given us the testing. Perfect. So that means in our data set, we would now use, so in this scenario, let me see if I can download it and quickly demonstrate what I'm saying. So in data set, standard practice is training, testing, training, validation, and testing. Training and validation will happen during training. Testing is a different ball game, right? So let me just quickly show you the way in, just like what he said, he's confused. We have training, we have testing data set. What should I do? I'm going to use CSV Reader. I'm going to use CSV Reader, right? I'm going to come here. I'm going to browse. I'm going to go to my downloads. I'm going to go to what I just downloaded. And I'm going to go with the training for the first one. Okay. I'm going to go with the testing for the second one. Blah, blah, blah. Downloads is this with the testing for the second one, right? What happened to the data? The data is not data anymore. So, let's check it out. Tests. Yeah, it's good. Train. Yeah, it's good. So maybe it has not downloaded finish. So we come here, downloads, one to this test, open. Something is wrong. The data row has too many different elements. There's something. Hold on, browse, training again. Training goes, testing again. Something is wrong with testing. But let's assume, okay, I don't know, it did not go, right? So let's assume, so this is what I'm going to assume. I'm going to assume this training is the testing. Let's assume this is the testing, there's no problem. What am I going to do? I'm going to come here, I'm going to, do category to number. I'm going to do partition. I'm going to do normalizer. I'm going to do normalizer apply twice. And I'm going to do linear regression. Linear regression. So, sorry, don't let everything come out or jump around. Let's bring it down. Let's come here. So, I'm rushing. That's why it is looking like this. I'm rushing category to numbers, partition will go to normalizer. Now, in this partition, I'm going to say, 70%. So this 30% is now my validation data set. This 30% is now my validation data set. And then I'm now going to come here. I'm going to train with the training, and then I'm going to validate. Now, this one, I'm going to Control V, the test data set. I will take it like this, but I won't partition it. I will now create another normalizer apply, another normalizer apply, and then take it to meet it. So this is now my test set. And then I'll create another. Am I making sense? Yes, I'll create. So this regression apply is going to validate my validation data set, and then this one is going to be my test. Where is it?
Okay.
Am I making sense?
Yeah.
Yes. So I want you in when I was talking about regression, intelligence cultivation. right? I want you to take this as a scenario where this validation test is now this in the curriculum. They have split it into what they will use to test, what they will use to teach, and what exam that they will set for your things they will set for your exam. But this validation test is now your tests and take-home assignments that they want to use to evaluate you. You understand? So just take it like that.
Okay.
So in many scenarios, standardly, there's a training data set, testing data set, and validation data set. Validation is midway. As we are training, are we doing the right way? Are we using the right technique? What is wrong? If it is wrong, we need to change technique before we get to the exam or before we get to the field. Make sense?
Okay.
Yeah.
So are we now having two predictions?
No. So you can see, no matter the number, you can have as much prediction as you want, but if you look at it, you only have one learner. Is this learner
One
that is
learner.
predicting here and predicting here? And you want it to be that as much as it's predicting, is predicting as accurate as you want.
Okay, but the learner now is predicting between the train and the validation test. That's the
So,
first. What I'm
so
seeing
the
in this
train,
diagram
yes, continue.
is predicting between the train and
Yes,
the validation, and it's
and
still
the test.
predicting between
No. And the test,
validation
you can
test.
see. You can see. So the trade. So look at it. This is
Okay.
I want you to put it like this. Maybe you are a lesson teacher. When you were
Okay.
training, this is what you expose the student to. You expose the student to this lane. But every time you go home, at their convenience, they can go through this data for their homework. Right? And in this
Okay.
place, before you bring the test sets, you will now evaluate, is the accuracy good or the accuracy is bad? Let me see if is the accuracy good or the accuracy is bad? Let me come to score. Right? Now,
Okay.
if the accuracy is bad, right? So is the accuracy good? The accuracy is good, right? Because the accuracy is good, I can now bring this learner and bring him here. If the accuracy is bad, I will come back and change my strategy. Do you understand?
Okay.
So because it's good, that's why this learner is promoted to this place. And now I can, what happened? I think there's something wrong with, because it's the same thing now. Right? Let's just take this like this. I can now come and predict and say, what is the score on unseen data? And it will come. Am I making sense?
Yes.
Thank you. So, any questions? Thank you for
Yes,
that.
please. Hello.
Yes. I mean,
Can we use the read image and image reader notes interchangeably?
Can we use can you say it again?
The read image node and image reader node, can we use them interchangeably? Because I tried downloading, I tried installing 9 image processing extension and it's giving me error. So I wanted to know if I can use the image reader in place of read images or something like that. I don't know if you get me.
Yes. I get you. I get you perfectly. So no, I need to play with read image. So you can see from the look of things, the image reader is it can take path as an input, but read images cannot take path as an input. So their inputs are different. You understand? So from the look of things, this will take a URL and PNG. This is taking a path, right? It's taking path as an input. So this one will let you read multiple images from a directory and display it in a table. That's what this one helps you to. Read images, I think it just goes, if you look at it, it goes to a URL or URL column, or reads from a location and reads an image, you can see, from a location.
Directly.
Yeah, yes. So they are different, right? But this one is good. So if you want to deal with bulky images, which is what we will do in this. As what type of system are you using?
My HP Windows with Windows. Yeah, Windows.
Let's see. Image reader. No. Yes, image reader. Table node not showing on what? 9. Let's see if it's a problem. And it's not okay, you can't even see it, right? When you try downloading, I want you to Google the error.
Okay.
Google the error and let's see what it is, and then you can post the error also on the group. Let's encounter it offline.
All right. Thank you very much.
You're welcome. So I see a number of hands are raised. Adoga. Any questions?
Sorry, that was must have been a mistake. Sorry.
Okay. So yes, I did not forget the assignment or the prize, but my thinking was some people will qualify. Obinna, any questions? You raised up your hand. Okay. Obinna, you can talk. Okay. So now, I'm not that occupation and this and that. They're supposed to be a qualification round for people that get more than 80%. That get more than 80%, and they will now think because a lot of people got 80% and above. But everybody submit it. I'm giving my third assignment today, and the third assignment is take this image data set where there's no time constraint and train it with this column, train everything. Thank God there's no results. There's no approach, there's no technique. You can apply normalization, you can apply category to many, you can reduce some of the columns, you can try any technique and get me a classifier that can tell me cat and dog with high accuracy. That is your assignment. Any questions? So finish the node, finish the work.
Sir, can you help us with the question in a structured manner?
I'm going to tell you, all the assignments are always written down. They're always here, and if you have questions, let me know. I would be, active on the Telegram group and answering questions, right? So, but so far, any other questions? So your assignment is finish this image classifier, image recognition, finish it, and let's know. Your next assignment is when Israel was talking, right? We talked about it. We are going to classify. We're going to classify. I think I got it. Ooh. We're going to classify human emotions. Yeah, where is it? Yeah. Right to me. Fish expressions. Okay. Nope, this is not it. Facial expression recognition. So you can see the string is validation. We have different data sets. We have angry, disgust, fear, happy, neutral. This is going to be your assignment next week, right? You can start working on it from now, but what you're going to do is use KNIME to what? Do facial expression recognition, right? So you should be able to recognize angry person's face. What does it look like? right? Sad person's face, what does it look like? Angry, fear, and everything, right? You know, we talked about it in class. We are going to work on it. So yes, any questions so far? So your first assignment is go and do this cat and dog. Know it very well, because once you do cat and dog, that's going to be binary classification. Then this one is just multi-class classification. So without taking any much of our time, in the absence of no questions, yes, somebody was saying
Sorry, sir.
yes, I'm here. Sorry, sir, I'm here. Okay, nobody's talking. So in absence of no questions, any questions? In absence of no question.
Did you finish the cat and dog one? Did you get to test the model?
No, because it's actually done. No, did it go? So it froze up on me, right? But this is at a stretch from here. So why I'm confident you can finish it from here, it is now very similar to the Irish that we did, because from when we get to partitioning, you can now decide to apply normalizer, you can decide to do regression or regressive classification, you can do any one you want. So my goal was to see you through and see that you understand reading the images, converting them to string, and getting to a place where you can partition. Right?
Okay.
Am I making sense? So let me show you. Right? Getting to a place where you know you can partition and you can classify. So from there on out, you are good. I'm looking for the previous one I worked on. So, but am I making sense? Hello. Do we have everything to do our assignment? Yes. If you don't want to answer, I'll answer for you. Yes.
Yes, I think so. Yeah.
Okay. No problem. Final round. Any questions?
So can we access all the assignments, the previous assignments from the deck in the classroom?
Yes. The deck is one continuous deck. You can access all the. Sorry, Damilola, are you a boy or a girl? Are you male or female?
A girl.
You are a female.
Girl.
I didn't want to.
Yeah, female.
Yes, okay. Are you based in Lagos?
Thank you. Nope.
Where?
Ibadan.
Ibadan.
Yeah.
Okay.
Thank you.
You're welcome. Gabriel, you raised up your hand.
Gabriel? I wanted to ask the possibility of getting this
the possibility of getting what? You died. Who is talking? Ayobami. Gabriel, continue.
I thought someone was talking. That's why I had to mute my mic. I was asking. I was asking how soon do we get the recording so that we can go through it?
You will get it immediately after the class.
That's fine. Where are you putting it on
in the classroom?
Telegram, right?
In the classroom group. In the Google Classroom. So if you come to the Google Classroom, right? If
you don't have a link to that.
You don't have a link to the Google Classroom. Let me give you. Sorry. Oribe, this is the link to the Google Classroom. When you go to the Google Classroom,
thank you.
Yes, it's going to ask you for a code. This is the code. I was ready. I didn't have it last week. This is the code. This is where you can see Josephine. Josephine now go and put a screenshot. Gang. Rich and poor. Gang. 100% accuracy. That's my Josephine. Gang. These are things that will make me happy. See my student. See, she bolded it. Kilo day. See Joy. A round of applause for all these people. Joy even arrange it like a car. This is good. This is good. This one is wavy. Who is this? Who is this? Let's see. Talile. Ima. This is good. 85%. 85%. So Josephine is leading. Damola. This thing is supposed to be full. You see, I've gone through the class of now. We know the partial winners, right? Josephine is the one that finished it. It was supposed to be rich and poor, right? I was looking for Obi Josephine. You sharply did it. You won't say anything.
No. I did not. I've done it since. Okay. But I noticed that it was not showing. The part I screenshotted was the accuracy side, not the other side, in the on Telegram page.
No problem. So we are going to take people. If you've not done it, 80% and above, you are going to qualify. If everybody gets 80% and above, then we will do it, and I'll give 80% and above. We want to see. I'm going to add a new ingredient so that we will single it out to one person that wins and wins it all. Right? So no problem. I will write the guidelines for the competition, and so that if people won't feel like I'm whining you. I'll write the guidelines for the competition, and then winner takes all. Someone said something?
Don't worry.
No, what did you want to say? Don't be shy. I won't bite. Okay. No problem. At least seeing response, seeing assignment, it made me happy. That I promise. Like, it made me happy. Made me happy. Thank you very much to everyone. To everyone that are still doing their assignment. I'm not even appreciating people yet. I know some people are still doing the assignment. They are going to upload. I'm going to be shocked. I'm going to be excited when I see the lines. But to everyone that are working on the assignment, about to start the assignment, downloading the data set, downloading the platform, you've made me happy. Thank you very much, everyone. So people have raised up their hands. Obinna. Gabriel, you raised up your hand. Okay. Obinna, you can speak if you want to. In absence of no more questions, thank you very much. Have a lovely weekend. On behalf of AIF, thank you. If you have any questions, challenges, please, drop it on the group, drop it on Telegram, drop it on WhatsApp, and, let's talk. So I will see you all next week. Please join early. We can start conversing even before the program starts and everything. So have a lovely, lovely day. Take care of yourselves. Bye-bye.
Thank you.
Bye-bye. Yeah.
Bye.
Good night.
Good night.
All right. Thank you. Bye.
Bye.